Have you ever made a choice and wondered, what if you'd taken that other job or said yes instead of no? What if I told you that every single one of those other paths might not just be a fantasy, but a reality playing out in another universe, parallel to our own? It sounds like science fiction, right? Something straight out of a comic book or a blockbuster movie. But what if the science is catching up to the fiction? Today, we're diving deep into one of the most mind-bending concepts in all of physics, the multiverse. Are there other versions of you out there, living lives you can only imagine? Let's find out. To really get our heads around this, we need to go back to the beginning. Not just the beginning of our day, but the beginning of everything, the Big Bang. For a long time, we thought our universe was the only one, born from an infinitesimally small, hot, dense point that exploded outwards about 13.8 billion years ago. This is the standard model of cosmology, and it works incredibly well to explain what we see around us, but it has a few quirks, puzzles that have led some of the brightest minds on the planet to suggest something even grander. One of the biggest proponents of the multiverse idea comes from a theory called eternal inflation. Imagine the Big Bang wasn't a one-time event. Instead, picture space itself as a gigantic, bubbling cauldron of energy, constantly expanding. Our universe is just one bubble that formed in this cosmic cauldron, a bubble that stopped inflating rapidly and cooled down, allowing stars, galaxies, and eventually us to form. But outside our bubble, the cauldron is still bubbling. New bubbles, new universes could be forming all the time, each with its own set of physical laws. In one universe, gravity might be weaker. In another, the speed of light could be different. Most of these universes would be sterile, unable to support life as we know it. But in an infinite sea of bubbles, some, like ours, would have just the right conditions. This idea is staggering because it means our universe isn't special because of some grand design, but simply because we won the cosmic lottery. We live in one of the bubbles where life was possible. But that's just one flavor of the multiverse. Let's switch gears and enter the bizarre world of quantum mechanics. This is the science of the very, very small, the world of atoms and particles, and down here, things get weird. One of the core principles is that a particle, like an electron, doesn't have a definite position until you measure it. Before that, it exists in a cloud of possibilities, a state called superposition. It's in all possible places at once. Now, what happens when you do measure it? The mainstream Copenhagen interpretation says that all those possibilities collapse into one single reality, the one we observe. But in the 1950s, a physicist named Hugh Everett proposed a radical alternative. He asked, what if the possibilities don't collapse? What if they all happen? This is the many worlds interpretation. According to Everett, every time a quantum measurement is made, the universe splits. In one universe, the electron is here, in another, it's there. Every single quantum event, from the decay of a radioactive atom to a photon hitting your eye, creates a branching of realities. This isn't just happening in a lab. It's happening everywhere, all the time. Think about it. The decision you made to watch this video in one universe, you clicked away. That simple choice could have spawned a new branch of reality. This means there's a version of you that became a rock star, an astronaut, or a professional chef. There's a version that never met your best friend. The number of parallel worlds would be mind-bogglingly vast, constantly splitting and diverging like the branches of an infinite tree. This is perhaps the most personal version of the multiverse because it implies the countless versions of you are out there, living out every conceivable possibility. So we have the bubbles of eternal inflation and the branching realities of quantum mechanics. Are there any other contenders, you bet? String theory, a candidate for the theory of everything, comes with its own multiverse model. String theory suggests that the fundamental building blocks of reality aren't particles, but tiny, vibrating strings of energy. For the math to work, string theory requires extra spatial dimensions, not just the 3 we know, plus time, but maybe 10 or 11 dimensions in total. So where are they? The theory suggests they're curled up incredibly small at every point in space. How these extra dimensions are curled up determines the laws of physics in our universe. But there isn't just one way for them to be curled up. In fact, there could be a colossal number of ways, something like 10 to the power of 500. Each possible configuration would create a different type of universe, a different brain floating in a higher dimensional space. Our universe would just be one of these brains. And sometimes, these brains could even collide, potentially triggering new Big Bangs. It's an entire landscape of possible universes, all predicted by the mathematics of string theory. Okay, this is all fascinating as a thought experiment. But is there any way we could ever prove it? This is the million-dollar question, and the biggest criticism of multiverse theories. Science relies on testable predictions. If you can't test a theory, is it really science or is it philosophy? For a long time, the multiverse seemed untestable. How could we possibly detect another universe if, by definition, it's separate from our own? But scientists are clever. They've been looking for subtle clues. For example, if our universe was once a bubble that collided with another, it might have left a bruise. This bruise could show up as a cold or hot spot in the cosmic microwave background, the leftover radiation from the Big Bang. Scientists have scoured the data from probes like WMAP and Planck, and while some intriguing anomalies have been found, there's no smoking gun yet. Nothing that definitively screams multiverse. Another long-shot idea is that if gravity can leak between dimensions or brains, we might be able to detect its subtle effects in high-energy particle collisions, like those at the Large Hadron Collider. So far, no luck. The lack of evidence is a major hurdle. Many physicists remain deeply skeptical, arguing that the multiverse is an elegant but ultimately unscientific cop-out. They say it's an excuse to explain away things we don't understand, like why our universe's constants are so finely tuned for life. If there are infinite universes, it's no surprise that one like ours exists. But critics call this a violation of Occam's razor, the principle that the simplest explanation is usually the best. Why invent an infinite number of unobservable universes when a single one is all we can see? The debate rages on in the halls of physics departments around the world. It's a clash of fundamental ideas about what science is and what its limits are. Is science only about what we can directly observe, or can it be about what our best theories logically predict, even if those predictions are beyond our current ability to test? So where does that leave us? Are parallel universes real? The honest answer is, we don't know. We have compelling theoretical reasons to think they might be. Leading theories like eternal inflation, quantum mechanics, and string theory all point, in their own ways, to a reality far grander than our single observable universe. These aren't just wild guesses, they are the logical extensions of our most successful scientific frameworks. Yet, we have zero direct, confirmed evidence. We are like ancient sailors who had just discovered their own island and were looking out at the vast, empty ocean, wondering if there was other land out there. They had no proof, only the belief that such a vast expanse couldn't be entirely empty. Today, we are those sailors, peering out into the cosmic ocean. The multiverse remains an idea on the very frontier of human knowledge, a concept that pushes the boundaries of both science and imagination. Perhaps one day, we'll find that cosmic bruise or that particle from another dimension. Or perhaps, the multiverse will remain forever beyond our reach, a tantalizing what if that inspires us to keep questioning, keep exploring, and keep looking up at the stars. The thought that there are other versions of you out there is both thrilling and a little unsettling. It forces us to reconsider our place in the cosmos. Are we unique, or are we just one data point in an infinite set? Whatever the answer, the quest to find it is one of the most exciting journeys in all of science. What do you think? Do you believe in the multiverse? Let me know your thoughts in the comments below. Thanks so much for joining me on this mind-bending trip through reality. If you enjoyed it, don't forget to like, subscribe, and hit that bell so you don't miss our next deep dive into the mysteries of the universe. See you next time.